Good morning, everyone.
Good morning, ma'am.
Good
Are
morning,
you
ma'am.
okay? Are
Good
you
morning, ma'am.
good morning? I just would like to inform you that your attendance is monitored and also the duration of your duration during the lecture. I will be sending to you who are those students who just stayed for seconds or minutes. Okay. Okay. And we will meet face. This is Black A, right? Mm. We will meet face to face on Thursday. We will start with a quiz, or the quiz that we are going that we regularly have, which is the milli equivalent computation, and the assignment that I am going to give you today. So I will only discuss the topics doable that are doable or that can be done online, and the rest of the topics that should need face to face will be discussed on Thursday. And let me remind you that the midterm examination will start on March 18. So we still have one more meeting for the topics included in the midterm coverage. Okay? Yes, kinsa to? Sorry, nawala ako sa connection. Are you in now, Miss Fajardo?
Yes po, Dean.
Okay. Okay. I will allow you to take a picture in the slides that I'm going to discuss. I will be sharing the slides only on the day, on let's say several days or a day before the examination or 2 days before the examination. So be you will be forced to take down notes or to take a picture on our discussion today. Okay, so you can have early uh, preparation for the midterm examination. I only have two topics to discuss this morning. As I have said, only those that can be discussed online. So, and those cannot be discussed online will be discussed next meeting when we meet on Thursday, and that will be our last meeting prior to the midterm examination. Can you see my slides?
Yes, Dean.
Yes,
And,
ma'am.
and can you hear me also clearly?
Yes po.
Yes po.
Okay. Kadyot lang sa ha, kay na ay message from the office. Now, we have discussed last time on acidimetry, right? Acidimetry, we have defined it, and there are two types of titration in acidimetry, direct and residual titration. We have discussed that. And when the basic sample is insoluble in water and the rate of its reaction with the standard acid is relatively slow, then residual titration is used to determine the amount of the analyte. So in acidimetry, the analyte is the base and the titrant is acid, or the standard solution is acid. Okay, we had this example or sample problem in acidimetry. I think we have this discussed last meeting. Okay, and we also had this introduce the general formula to determine the percentage amount of the substance desired or the amount of the analyte weight divided by the weight of the sample or volume of the sample times 100, you get the percentage amount of the sample or analyte, okay, or substance that is desired to determine of its amount. Then we also had this discussed last time, residual titration or back titration. And we had this problem, sample problem for residual titration. Okay, the chemical reaction. In this chemical reaction, it shows that the analyte, magnesium hydroxide, which is present in magnesium magma, will react or reacts first with sulfuric acid, and the excess sulfuric acid will react with the second titrant sodium hydroxide. And this can be determined, the amount of magnesium hydroxide present in the sample can be determined by the MEQ of the acid minus the MEQ of the base. So what is the difference? The difference would be the MEQ of the acid multiplied to the milli equivalent of the analyte, which is magnesium hydroxide, which will give you the weight of the analyte, magnesium hydroxide, divided by weight of the sample times 100. You will get the percentage amount of magnesium hydroxide present in magnesia magma. We had discussed that last time. Okay, now in continuation with acidimetry, in acidimetry, we know that the analyte is, what is the analyte in acidimetry? Miss Odiada, what is the analyte in acidimetry? Miss Odiada, are you there or I will mark you
Yes,
absent?
ma'am. Yes,
Okay,
ma'am.
what?
Good morning.
Good morning, very good. So what is the analyte, Miss Odiada?
Analyte is the standard solution, ma'am.
Is the
Standard solution po.
analyte and standard solutions are two different things. Okay. Now in this problem, uh, I am asking you in acidimetry, what is the analyte? I am not asking you to define the analyte, but in acidimetry, what is the analyte? Miss Odiada? Okay. Please
Um,
chat your answers.
okay, ma'am.
Please chat your answers. What is the analyte in acidimetry? Yes, it is the
And
base. So, ang analyte sa acidimetry, the base. So, Miss Udyada, what is the titrant in acidimetry?
It is the acid, ma'am.
Okay, acid ang titrant sa acidimetry. Very good. Okay. So, in this determination of nitrogen in Bicaldal method, nitrogen here, which still belongs to acidimetry, is a base. And this can be determined by Kaldal method. So substances containing nitrogen belongs to are bases. So basic sila kung naay nitrogen. And this nitrogen can be determined by Kaldal method. How? Now, organic material contains nitrogen. Substances that contain protein also has nitrogen. And this nitrogen can be extracted or converted to ammonia. How? So the organic material will be digested with concentrated sulfuric acid in the presence of a catalyst. The concentrated sulfuric acid here is not a titrant. It is used to digest the organic uh, material that contains nitrogen. And this organic material will be digested with concentrated sulfuric acid, will be converted to ammonium bisulfate. And then this will be added with excess strong sodium hydroxide. Again, this is not the titrant. This is not a titrant. This is part of the process in determining nitrogen by Kjeldahl method. So after adding excess strong sodium hydroxide, ammonia gas is liberated and absorbed in the measured amount of standard acid solution. So it is now the nitrogen in ammonia gas that is titrated with standard acid solution. So these two are not titrants, they are reagents that are used in the process to extract the nitrogen from the organic material. This process is known as Kjeldahl method, which determines the nitrogen from the organic material. Okay. Now, this is a sample problem of nitrogen determination by Kjeldahl method. So again, the nitrogen can be determined by Kjeldahl method, and the process is this one. If you have the book, this is the schematic diagram illustrated or taken from the book. Okay. The sample problem for nitrogen determination by Kjeldahl method is the determination of nitrogen content. Determination of nitrogen content of 2-gram mongo beans, which was digested with sulfuric acid, and the distillate acidified with 26.24 ml of 0.12 normal HCl, then titrated with 17.10 ml of 0.01 normal sodium hydroxide using phenolphthalein as the indicator. Now, question. The sample is mongo beans. What is the unknown? What is asked in the problem? I hope you already had taken the picture, so I can call you. Okay. What is asked in the problem? Anyone? Miss Fajardo. Or you can chat.
The normality, ma'am.
The percentage of nitrogen. Yes, you are correct. And the
Nitrogen.
okay, and the sample is, what is the sample? Anyone, please chat. Chat your answer. Mongo beans. So what is the story of the problem? The mongo beans is digested with sulfuric acid, and then ibutangan og strong sodium hydroxide, and then mo yield siya og ammonia. So it's the nitrogen present in the mongo beans that is going to be determined pila ka percentage. Okay? And based on the problem, what type of titration is this? You can chat. What type of titration? What type of titration is this? Kung sa ganitong mga types of titration, okay, you have this titration carries residual titration. Okay, what are the titrants and what among the two titrants, what titrant reacted with the analyte or with nitrogen or with the sample? Which of the two reacted with the sample? Anyone? Okay, please check your answer. Is that correct? Sodium hydroxide? It is always the first titrant. Yes, correct. It is always the first titrant that will react with the analyte. Now, the analyte is a base, so it has to be reacted with the acid, sulfuric acid. And the second titrant, what is the second titrant? Please chat your answer. What is the second titrant? Sodium hydroxide is the second titrant. And the second titrant will react with excess HCl. Okay. Okay, thank you. Now, this will apply the formula on residual titration. Dili ni mao. On residual titration, this one. Okay, this will apply, the problem will apply this formula since there are two titrants and this is the formula to determine in for residual rather, for residual titration. Okay, I will ask you to compute in your places, in your homes, and be ready to present this next meeting. We will discuss this next meeting and be ready to present. We will not discuss it here because it's difficult for me to discuss this uh, in online. Okay. Now, since nitrogen, percentage of nitrogen is the one determined, what what substance are you going to compute for the milli equivalent weight? Nitrogen, HCl, or sodium hydroxide? Which of the three substances are you going to compute for the milli equivalent weight? Nitrogen, HCl, or sodium hydroxide? Chat your answer. Yes, it's nitrogen. So the number of MEQ times the milli equivalent weight will give you the weight of the desired constituent. Now, since nitrogen has atomic weight of 14, okay, check that in your periodic table. Since nitrogen has atomic weight of 14, you are able to determine the percentage amount of nitrogen. We will not discuss here, but make sure you can compute that in your places. Okay, let's continue. So we are done with acidimetry. Let's now move on to alkalimetry. This is determination of acid using standard alkali solution. So for alkalimetry, the analyte is acid, the titrant is base. For acidimetry, the analyte is base or alkali, the titrant or standard solution is acid. Now, the direct titration for acid for alkalimetry is example is assay of HCl. In the assay of HCl, that the analyte is HCl, the titrant is sodium hydroxide. So alkalimetry, the titrant is base and the analyte is acid for alkalimetry. For direct titration, example is the assay of HCl. In other words, HCl is assayed by direct titration alkalimetry. Okay. Now for your assignment on residual titration, look or read the assay of zinc oxide in your Jenkins book and assay of aspirin capsule also in Jenkins' book. Read the assay. So for the assay of aspirin capsule, this will be your guide. For the assay of aspirin capsule, know the chemical name of aspirin, know what is the analyte, what kind of neutralization is applied in the assay of aspirin, what type of titration is the assay of aspirin. When we say kind of neutralization, is it acidimetry or alkalimetry? When we speak of type of titration, is it direct or residual? And mention also the titrants. Okay. Now, in the assay of aspirin, there is what we call blank determination or blank titration. This is done in the assay of aspirin. And what does this mean? It means that using the same quantities of the same reagents in the same manner under the same condition but without the analyte. Have you performed this in the laboratory? Na-perform na ba din ninyo? Yes or no?
No pa ata.
Wala pa. Unsa may last ninyo nga gi-perform sa laboratory?
Titration to, ma'am, last
Okay.
Wednesday.
Oo, unsa inyong gi-titrate? Titration man gyud ta ani kay volumetric pan. Unsa inyong hanggit? What's the title of your last experiment sa QC sa analysis 1? Unsa man inyong hanggi buhat sa titration? What was the titrant and what was the analyte? Miss Gampong, did you perform your experiment? Miss Gampong, are you in? 1, 2,
Yes,
wala.
ma'am.
Yes, okay, good. Did you perform the
Yes, ma'am.
in your laboratory?
Yes, ma'am. About
Okay.
titration po, ma'am.
Yes, what did you titrate? Unsa may title ato? Unsa may titration inyong gibuhat?
Exact, ma'am.
Oo, yes, you're raising your hand, Mr. Yap.
Ma'am, matutulukan, ma'am.
Natuplokan.
Pero,
If you remember, unsay inyong gititrate last time sa inyong laboratory?
laboratory, ma'am, kuan, ma'am. Sodium carbonate, ito, ma'am.
Sodium carbonate
Opo.
with ang titrant ninyo is sodium carbonate. Unya, ang analyte is
Sulfuric acid, and no, oh,
sulfuric
opo.
acid.
Sulfuric acid po, ma'am.
Ma'am.
So what did you do? Did you assay sulfuric acid or did you standardize sodium hydroxide? Or ka-standardize mo o nag-assay mo?
Assay,
Hmm?
ma'am.
Nag-assay mo sa HCl, ay sa sulfuric acid. Inyong gi-assay ang sulfuric acid. So, with that as
Standardization.
standardization or
Ang
nag-standardize
sulfuric,
mo?
ma'am, gi-standardize na mo, ma'am.
O sa may title, gipangita ninyo ang normality sa sulfuric o normality sa sodium hydroxide. Unsa may answer ninyo? Unsa gipangita?
Average
Is it
of normality, ma'am. Standardization.
normality? So
Normalities, ma'am.
kung okay. So kung normality ang inyong gipangita, you are assaying or standardizing?
Standardizing po, ma'am.
Yes, because when you assay, you determine the percentage, purity, or amount of the analyte. When you determine the normality, you are standardizing. Okay? Okay. So, anyhow, in the in the titration, you had determined the normality of sulfuric acid ba using sodium hydroxide. Yes? So, ang inyong gigamit nga way of standardization, primary standard or secondary standard? You have to analyze that go back to your laboratory and analyze what type of titration, what type of neutralization, is it acidimetry, alkalimetry, what type of standardization, is it with the use of primary standard, or is it with the use of a secondary standard? So based on that, with that experiment, so i-apply na to ang inyong theoretical knowledge obtained or acquired sa lecture, apply ninyo sa laboratory so that there will be continuity in the knowledge and understanding of what you are doing in the lecture and application in the laboratory. So, dunay meaning ang inyong pagtuon sa analysis. Okay, let's continue. Now, we were talking about blank determination. Now, when you are going to perform the assay of aspirin in the laboratory, you will be able to experience blank determination or blank titration, in which this is done by using the same quantities or amount of the same reagents. So, whatever reagents titrants gigamit sa assay of aspirin will be the same, will have the same quantities in the same manner under the same condition, but without the analyte. That's why it is blank titration or blank determination, because there is no analyte. And what is the purpose of this? It will correct the presence of impurities in the reagents. So, if you will perform the assay of aspirin and you will encounter the blank titration or determination, that would mean that everything is the same. The reagents are the same, the quantities are the same, the condition wherein when the performance is done is the same, but without the analyte, meaning walay aspirin. Okay, and that is blank determination. So any blank determination performed na ang reagents, the same quantities, the same condition, the same manner of adding, but there is no analyte. Okay. Okay. Now let's move on to non-aqueous stoichiometric analysis. When we say aqueous stoichiometric analysis, that means that the solvent used in dissolving the analyte is water. Therefore, the analyte is soluble in water. And substances that are not soluble or poorly soluble in water, they can be also analyzed with the use of non-aqueous stoichiometric analysis, or dili tubig ang gamiton. There will be solvents appropriate to dissolve, or suitable solvents to dissolve the sample or the analyte. So with non-aqueous titrimetric analysis, this will not use water. And what are the kinds of analytes is that qualifies for this non-aqueous titrimetric analysis? The characteristics are those that are poorly soluble in water and weakly reactive with water. So, in acidimetry in non-aqueous titration, these are the analyzed weakly basis substances. Example, amines, amine salt, heterocyclic nitrogen. This will be the analyte, or these are the examples of analytes that are weakly basic for non-aqueous acidimetry. Okay, those are the analytes, sample of analytes. And then since water is not used, solvents used in acidimetric titrimetry are either relatively neutral or acidic in nature. So in other words, mogamit sila og solvent, gamitan ni siya og solvent dili tubig. And it could either be neutral or acidic in nature. And the choice of solvent is determined on the basic character of the substance to be assayed. I would strongly recommend you to read the book to understand better on the basic character and what manner is the choosing or selecting of the solvent. So examples of neutral solvents are acetonitrile, alcohols, chloroforms, benzenes, dioxane, ethyl acetate. These are example of solvents that are used to dissolve the analyte for titration, and these are neutral solvents. There are also acidic solvents. Example, formic acid, glacial acetic acid, propionic acid, acetic anhydride, sulfonyl chloride. Now, these are acidic solvents used to dissolve the weakly basic substances. Okay, again, since these are substances that are not soluble in water, suitable solvents will be used to dissolve the analyte. And these solvents could either be acidic in nature or neutral solvents. And the choice of solvents will be determined on the basic character of the substance to be assayed. Kay acidimetry man ta, the analyte or the substance to be assayed is base. Okay, so these are examples of neutral solvents used to dissolve the basic substances, and here is also examples of acidic solvents. So you have that solvents and the titrant. So we are done with the analyte for non-aqueous titrimetric acidimetric method of analysis. Okay, that is the analyte. These are the examples of solvents. Dili man mo gamit og tubig. And then let's go now to the titrant. Sa acidimetry non-aqueous titration, unsa may titrant gigamit. The most valuable and widely used titrant is perchloric acid in glacial acetic acid or neutral solvent. Meaning, si perchloric acid, kung kani ang gigamit nga solvent, this solvent sa analyte, this is widely used as the titrant or pwede pod siya sa dioxane. Kay si dioxane is a neutral solvent. Si glacial acetic is acidic solvent. So depende sa analyte na siya. Perchloric is the strongest of the known common acids which gives excellent result with practically all known weak bases. So popular yun ni si perchloric acid as titrant in weak bases as analyte. So since perchloric acid is the titrant, which is also known as the standard solution, this will be used for titration or titrant in the analysis of weak bases. Now, what are the indicators used in the titration of weak bases? So these are the indicators used: crystal violet, methyl rosanilin chloride, quinaldin red, alpha naphthol benzene, and malachite green. These are examples of indicators for weak bases and their salts. With relatively strong bases, methyl red, methyl orange, and thymol blue can be used. So ang indicators would also be used to suit the weak bases and their salts, and these are the examples. Take a picture of this. So perchloric acid, which is a standard solution or the titrant, is standardized. And this can be standardized with glacial acetic acid as the solvent for acidic. Acetic anhydride can also be used as the solvent for the analyte. Then the primary standard to standardize perchloric acid is potassium bitalate. The indicator used is crystal violet and endpoint is emerald green. So in standardizing perchloric acid, what is the sample used to standardize perchloric acid? Kung mag-standardize ka, mogamit magka og carefully weighed sample. So to standardize perchloric acid, what is the sample used to determine the normality or to standardize to standardize perchloric acid? Anyone? Kung sa ganito'y definition sa primary standard, anyone? Panda. Yes, Badad.
Yes.
Kuan, ma'am, way of sample known as purity.
Sa? Please read your definition correctly.
Primary standard is a carefully weighed sample of known purity.
Carefully weighed sample of known purity. Okay, read further to because I have to clarify something diha. What's next in that description?
Are primary reagents that are extremely pure, stable, and has no water of hydration, and are used for standardization of volumetric solutions, also known as volumetric standard or standard solutions.
Okay. So it is used to standardize volumetric solution, also known as standard solution. Kana nga statement daghang nasayop ana pag-define sa primary standard kay gipareho nila ang primary standard also known as secondary standard. No, it's not. Read between the line. It is used to standardize volumetric solution also known as standard solution. Dili is standard solution also known as primary standard. Got it? The primary standard used to standardize, the primary standard used to standardize volumetric solution, also known as standard solution. Gets ninyo? Gets ninyo? Okay. So a primary standard is a carefully weighed sample. It is not a solution. So it is never be the same as also known as standard solution. It's never be like that. Ha? Okay. Basta ha gani ninyo maayo ang definition, so you will not be misled. Kay wala ninyo giapil og basa ang it is used to standardize na unya ang tumoy ra inyong gibasa na miss out ninyo ang it is used to standardize. So ang inyong pagtuo, the primary standard and the secondary standard, the primary standard and the volumetric or known as standard solution are the same. So dili na ha, klaro. I have read several definitions sa primary standard in the quiz. Okay. So, in this problem, in dili problem, in this standardization of perchloric acid, what is the sample? What is the carefully weighed sample? Unsay gigamit nga sample to standardize perchloric acid? Anyone? Tana may copy? Yes, Miss Gagarin.
Potassium biphthalate, ma'am.
Yes, potassium biphthalate. Potassium biphthalate is the primary standard, and the definition of a primary standard is a carefully weighed sample. It is used to standardize the standard solution. So, si primary standard biphthalate, gigamit na siya to standardize perchloric acid. Muna to ang last nga description nga, it is used to standardize volumetric solution, also known as standard solution. Gets ninyo? Okay, very good. And the indicator used in the standardization of perchloric acid is crystal violet, and the endpoint is emerald green. Okay. So in acidimetric assays, non-aqueous titration, these are sample substances or therapeutic agents that can be assayed by non-aqueous titrimetric acidimetric analysis. Non-aqueous acidimetric non-aqueous analysis. Example, assay of pethacholine chloride. Bisacodyl, kani si bisacodyl dulcolax ni siya. This can be assayed by acidimetry non-aqueous titration. So unsay titrant gamiton ani? Perchloric acid. Si diazepam, acid ni siya or base? Ah, acid or base? Napata sa acidimetry, correct? So, in acidimetry, unsa may analyte, acid or base?
Base po,
What?
ma'am.
Yes, base. So, si diazepam is base. Kaila mo diazepam? Wala pa mo kaila og diazepam. What about bisacodyl, dulcolax? Dulcolax is also a base. Epinephrine is also a base. So, these are example of therapeutic agents that are acidimetric non-aqueous titration. Okay. So again, the primary standard used to standardize perchloric acid is potassium biphthalate. Know the formula, molecular formula of this potassium biphthalate. And the titrant used in acidimetric non-aqueous titration is perchloric acid. So, kung perchloric acid, ang solvent gigamit to dissolve the analyte is glacial acetic acid. So, glacial acetic acid is the solvent. Perchloric acid is the titrant. Dili bali, ha? Dili interchange. Solvent si acetic, titrant si perchloric. Okay? Let's move on. In alkalimetry, non-aqueous titration, these are the solvent. So in alkalimetry, unsa gani ang analyte?
Acid, ma'am.
Acid,
Acid
ma'am.
po,
Acid.
ma'am.
Yes, so klaro kay siya no, the analyte acid halides. So meaning acid nga weak acid, ha? Acid halides, anhydrous amino acid, barbiturates, xanthines, imides, phenols, sulfonamides. Okay. Those are example of analyte. So, ang solvent gamiton. Sample for strong bases, you have ethylene diamine and butylamine morpholine. For weak base, dimethylformamide, pyridine. These are the solvents. Dili titrant sa solvents ni. The titrants used or standard solution used in alkalimetric non-aqueous. You have sodium methoxide, lithium methoxide, sodium amino methoxide, and sodium triphenylmethane. And the most commonly used are the sodium methoxide and lithium methoxide. And we will discuss only more on sodium methoxide. And these are sample indicators, thymol blue, azo violet, and orthonitroaniline. Okay. So in the standardization of sodium methoxide, okay, sodium methoxide is the titrant or the standard solution for acidimetry, alkalimetry. Standardization of sodium methoxide. So sodium methoxide is the titrant used in acidimetry or alkalimetry. Non-aqueous
Alkalimetry po.
yes, alkalimetry. And the primary standard to standardize sodium methoxide is benzoic acid. Know the molecular formula of benzoic acid. The solvent is dimethylformamide. Indicator use is thymol blue in dimethylformamide. So kung thymol blue in dimethylformamide, meaning to say the solvent use should be dimethylformamide. And the end point is blue color. Okay? Now, for the alkalimetric assays or therapeutic agents that are assayed alkalimetric non-aqueous titration using sodium methoxide as the titrant or standard solution are the following. Assay of phenytoin. So therefore, phenytoin is acid or base. Acid or base si phenytoin? Weakly acid or weakly base? Kung alkalimetry, the titrant is sodium methoxide. Acid or base? Ano si phenytoin? Acid or base?
Base, ma'am.
Ma'am.
Which one is base? Si phenytoin or si sodium methoxide?
Phenytoin, ma'am.
Phenytoin ang base sa ato pa. Ang analyte sa alkalimetry is base. Unsay analyte sa alkalimetry? Acid or base?
Acid po.
Okay, so phenytoin therefore is weakly acid. Are you following? So pentobarbital is weakly acid, amobarbital, and secobarbital. These are the analytes or therapeutic agents that can be analyzed or assayed by alkalimetric non-aqueous titration. So, in this titration or assays, what you have to know are example sa alkalimetry non-aqueous titration. Unsa may analytes ani? So you have here the sample. So in other words, sa titration, ang dapat mahibaw-an ninyo unsay analyte, unsay solvent for non-aqueous, unsay titrant and indicators, unsay primary standard to standardize, the indicator and the end color, and the sample substances to be analyzed. Sa ato pa, kung kani siya alkalimetry, kaning mga substances diri therapeutic agents are basic. Basic ba? Acidic. Okay. Okay. Are you following? Pareho raman na sila. O, pagbalik na to sa non-aqueous titrimetric, you have acidimetry, you have the analyte, then the solvents, then the titrant, then the indicators. Mga na siya. So, you can tabulate this. Karon at one glance, you are able to identify and easier for you to memorize and study. Pareha sa gibuhat nako aning pag-tabulate sa acidimetry and alkalimetry. Pareha ani. So neutralization methods, acidimetry, analyte, then titrant use. So you can also do this instead of neutralization, you can do this in non-aqueous titrimetry. You can have acidimetry, alkalimetry, solvent, then analyte, then titrant, indicators, and end point. You can do that. Okay? Let's move on. Okay, next we are done with neutralization. So under neutralization, we have acidimetry and alkalimetry aqueous solvent. You have non-aqueous titration, acidimetry, and alkalimetry. Those are under neutralization. Now let's move on to another type of chemical reaction, which is the precipitation and complexation. Now neutralization, in neutralization, there is the formation of colors at the end point in the presence of indicator. That is one of the distinctive characteristics of neutralization, the use of indicator and the change of color because of the change of pH in neutralization. Now, in the precipitation, it's different. In the precipitation, the volumetric precipitometry requires the formation of insoluble substances or precipitate to cause the reaction to go sufficient completion to be quantitative in nature. So, how to quantify or how to determine the amount of the desired constituent, while in neutralization it is a change of color. The risk of precipitation is the formation of insoluble substances or precipitate. So that the determination of the endpoint is cessation of precipitation or appearance of turbidity, or use of internal indicators or instrumental method. Now, in this discussion, we will only focus on the cessation of precipitation or formation of insoluble substances or precipitate or appearance of turbidity. So the endpoint determination is what? Precipitation and appearance of turbidity. Now, in this precipitation method, the indicators are important. And these are the three indicators normally used: the ferric ammonium sulfate test solution, know the formula; potassium chromate, know the formula; and then adsorption dyes. These are the indicators used in the precipitation method. And the standard solutions or the titrants are silver nitrate and ammonium thiocyanate. So these are the titrants for the standard solution. Now, the standard solutions, silver nitrate and ammonium thiocyanate, are the ones to be standardized. Now, the type of titration that is applied in here is our direct titration or residual titration. Now, the standard solution is silver nitrate is standardized using diluted HCl. Now, I cannot discuss this thoroughly by online, but we will do the discussion by face to face. This will be discussed on Thursday, our next meeting on the computation of normality sa silver nitrate. Now, you will notice here in the chemical reaction, the standard solution is silver nitrate. This will be reacted with HCl, dilute HCl, and will form white curdy precipitate of silver chloride. This is the focus on the computation of normality. This will be used in the computation of normality of silver nitrate, which will be discussed on Thursday. Another standard solution is ammonium thiocyanate, and this will also be discussed face to face because this needs to be discussed good, yeah, daily online. Okay. This will be the next topics: residual titration, direct and residual titration, and the summary table for precipitation. Then we will discuss the complexation methods also on Thursday, and which is part of the midterm examination. So for Thursday, we will again have the quiz, which I promise to have a quiz always on a milli equivalent weight computation, and the assignment that I gave on zinc oxide and aspirin. Ah, katulang usaang i-focus ninyo for the quiz, ang assignment, and we will continue the discussion on Thursday on precipitation and complexation. And of course, the discussion of the normality discussion sa silver nitrate. So you notice that wala ko'y normality computation sa perchloric acid. Kaya lisod ang computation online. Okay? So that's all for our lecture today. Only 1 hour. Yes, and if you have questions, you may stay. Are you raising your hand? Yes, Parba?
Yes po. Ma'am, good morning.
Mm,
Regarding the assignment po, asa po
mm.
siya ibutang
No, basahon
sa
ninyo kay mo
activity
na
note paper,
focus.
ma'am?
No, you only have to read that because that will be the focus of the quiz. Assignment ninyo to read.
Oh,
Kay mao na atong i-quiz
okay po.
next meeting. Okay?
Thank you po.
You're welcome. Any more questions? Okay, you may now leave. Kung walay
Regarding
questions.
time, ma'am.
Bye-bye.
Thank you,
Bye,
ma'am.